Alright, so hello. In this video, we'll further elaborate on the properties of a vector. So we're going to talk about the properties of our well-known vector. What's a vector is something that we've already covered in our previous video. And just to recap on that, we have defined a vector as a quantity, as a physical quantity that includes two key aspects: a magnitude and a direction, because there are times when defining physical quantities, just knowing the magnitude doesn't help. There are times when the direction is also needed. And a very clear example to understand why that's the case is if you consider a quantity like force. We know force is a vector, but there's a reason why we need a direction in addition to a magnitude, because the same force applied in a different direction completely changes the dynamics of what's happening. Now, say, for example, you have a straw, like a straw, like your regular straw, and you have like a piece of paper crumbled in between that can be used as a weapon in many cases. It's rather fun to work with. So you have that piece of paper, and say we call it a particle of mass, say m, right? Let me just get rid of that arrow, it may confuse us later on. So that's our body, and it has a mass of m. Now, let us see what happens to this body if you apply two different forces. Now, the first force that we apply is, say, in the direction along the tubing of the straw. That means in this direction. This is the first force. I'm going to write that with a vector sign, an arrow above the letter F. So that's the force being applied in the direction along the straw. So we know that because there's no resistance whatsoever, and the body or the paper ball can actually move up and down. So this will result in motion upwards, right? So that gives us some sort of dynamics. Now, the reason I've done this, that I've applied the force along the tubing, is to compare it in another case in which the same force, and when I say same force, I mean the same magnitude of the force. Magnitude is held constant. And the way I do that is I ensure that the length of the vector, this length, is equal to this length of another vector, but this vector now points perpendicular to the direction of the tubing. Now, because this body is snugly fit within the straw, the paper is snugly fit within the straw, it can't move along the direction perpendicular to the tubing. And so, no matter how hard I apply this force, this body won't move. So the dynamics have changed. Even if I apply the same force with the same magnitude, but in a completely different direction, perpendicular to be exact, the body doesn't move. So that's weird. So we can't really think of forces as scalars anymore, because even if we have the same magnitudes, the forces completely change the dynamics when the directions differ. So we also have to consider directions for quantities like forces, and that's a very strong reason why a force is a vector and not a scalar. So with that out of the way, with that just a basic recap, we can actually go on to talk about a few characteristics of forces, shall we? So the first thing is, as you've already noticed, that a vector is represented by a capital letter. Now, I can start with, say, letter A, and I always put an arrowhead on top of A. And that tells me that if I'm talking about forces, or like vectors in general, basic vectors, could be force, velocity, acceleration, could be anything like that sort, then we know that this is a vector because of the fact it's represented by a capital letter. That's just the representation, and also an arrowhead. Now, the arrowhead doesn't really mean that the vector is pointing in this direction. It's just a way of calling what vector we actually choose to work upon. Now, this is just the abstract representation of the vector, but the actual representation of the vector is given by an arrow of a particular length. So if this is our vector A vector, then I would call it by A with the arrow on top, and I would draw it with the direction which I want my vector to be, and of a finite and a known length. The length would be from the base of the arrow to the head of the arrow. And this length would give me a sense of the magnitude of the vector. So if I have another vector, say, in the same direction, but of a length which is clearly greater than our previous vector A, and I call that vector, say, vector B, then just by the fact that the magnitude is different and is larger in this case, because the magnitude here, which is given by the length again, is greater for B than A, then we know that B is a stronger vector than A. So if this were two forces which were being applied on same bodies of, say, mass m, then this body will move faster than this body because it's been acted on a greater force. And the greatness of the force is determined by the length of the vector. So the length, the magnitude, is given by the length, and that's how we draw them. And the direction, as it will be clear, is given by the direction in which the arrow is oriented. So that's how we draw vectors. Now, many times we would want to work just with the magnitudes of vectors at times. So in those cases, we represent a magnitude of a vector, say magnitude of vector A, is something that we call by the following notation. So it's a vector, but enclosed in a modulus. Now, if you go back to your mathematical classes and your maths books that you've gone through already, you know that a modulus of, say, any number x is, well, x if x is a positive number or equal to 0, and it's negative x if x is less than 0. That is to say, if you have, say, modulus of 2, then because 2, hence x, is greater or equal to 0, then modulus of 2 is 2. But modulus of negative 3, because that's negative, would be negative of negative 3, and hence would be positive 3. So clearly, modulus gives you a positive value. So therefore, the modulus of a vector, by using the mathematical description of the function of modulus, in physics, we can know that the modulus will always be a positive quantity. So if my vector A is, say, 5 meters long from base to head and point in the northeast direction, then the modulus of A would be 5 meters. Simple as that. So when I call out the modulus of any vector, I basically limit my observation just to the magnitude. So it's basically that we have gone back to the realm of scalars from vectors, the vector being A and the scalar being modulus of A. So that is how we call as our magnitude of a vector. Now, if I make some space and get rid of this, I can talk about what we call the direction of a vector. Now, there would be cases later on that we would want to work just with directions. And if we are given a vector A, as it were here, of some length, the length would be modulus of A, that means it is this much long, then the direction of the same vector A would actually be given by, this is just another representation, A with a inverted V on top of that. So that's what we call A hat or A cap. That's the two ways I know how to call it. So I think that would be enough to just get a head around what direction is of a vector. So when I say that the vector has the direction of A hat or A cap, the vector A has the direction of A hat, then A hat basically means that this is just another vector, but we're working with a known and a uniform and a basically a unit magnitude. So if this were a vector of, like a previous example, 5 meters, then A cap or A hat would have been the same vector, a different vector, but with the length of 1 meter. And the reason we choose it to be a unit length is because if I multiply this with any other direction, or I choose to work with just changing its magnitude, then I can do that because 1 times any number is the number itself. So with that in the back of your mind, we can analyze why do we need a direction, and if so, why do we represent it with a unit length vector? So direction is also in some regards another vector, but with a magnitude of 1. So if I clear this off again and try to work with, say, another vector, and now this time we go a bit more mathematical, and I draw the vector in this direction. So the vector is formed in between 2 coordinates, the base being at 0, 0, and the head being at 3, 4. So that is to say that in order to reach the head from the tail or the base, I had gone 3 units, like so, in the x direction of 3, and I had gone 4 units in the y direction. So that is where the head is located if the base is at 0. That's, say, my vector v. Now v, capital V, with a arrow on top. So that's my vector v. Now I ask you, what is the magnitude of v? Now what is that? And from a previous discussion, we know that the magnitude is basically the length of the vector, and from a coordinate geometry analysis, we would know that if this is point O and this is point V, then OV would be the magnitude of V. And OV would not be nothing but 3 minus 0 square, difference in the x coordinates and the difference in the y coordinates. Square them up, add them up, and take the root of that. And it is a very simple mathematical operation. This gives you 9, this gives you 16, and root of that, you get 25, root of that, and you get 5. So the length of the vector, and hence the magnitude, is 5. So if this were, say, displacement, that means just the length, then the magnitude of v, or basically modulus of v, would have been 5 meters if these lengths were measured in meters, both of them. So that is what our magnitude of the vector is, just the length of that. And the direction would be the direction in which the arrow is pointed. So one way to really work out your direction is just by knowing the angle in which this arrow is pointing. The other way is, as I've already discussed, is letting us know what a v vector looks like, v hat vector. Now v hat vector is a special vector with a unit length. That means the magnitude of v vector is 1. If I write this, then that should be 1 meter. And that is to say that if I again draw my coordinate axes, and if I need to draw v vector, then I draw a parallel line to the line in which our vector v was oriented, but I only go in a unit length from the origin, so that's 1 meter there. This gives me the direction in which the original v vector was pointed, and this is the vector v hat or v cap. So that is the property of the directional vector of the vector v, which is just a v hat vector. But more importantly, the magnitude of the vector v was given by the length, and we were able to evaluate that just by using the distance formula. And that was it. So this is how you work out what a vector is, how it looks like, what are the properties, and we have discussed so far 2 basic properties of every vector, the magnitude and the direction. And I hope this video is clear and it's made sense to you and helps you in your further studies. So all the best.